Good morning. I am Srilekha, Department of Chemistry. Now I am going to take about on the DT-based decision thinking concept of the conductometry experiments, that is a mixture of acid by using this HCl and acetic acid. So this is the experiment, and the aim of this experiment is nothing but to determine the amount of a strong acid and the weak acid which is present in the whole of the given solution. A standard solution of 0.1 sodium hydroxide solution is given in this apparatus. So now I am going to take the burette solution of, what is the burette solution? Sodium hydroxide. And what is the pipette solution? Mixture of acid, that is HCl and acetic acid, which is combined together. And what is the conductivity? Conductivity cell we are using it. And what is the temperature? Conductance value. We are noting the conductance value for this experiment, and the experiment throughout the continue by using this room temperature. Okay. So from this experiment, for the burette solution which I am adding is a 1% of the sodium hydroxide in the burette. So the burette solution is filled with 1% of sodium hydroxide, and the pipette solution is mixture of acid by 20 ml. For diluting the solution, I am adding the distilled water and make into a solution as 40 ml. So the solution started with this 40 ml and the burette solution with this 0 readings, and we are for conducting these two equations. I am using this conductivity cell for the conducting values. So for this 0 value of the solution, the value decreases to 6.59. So this is the first experiment introductions to 0 value, and again the values can be decreases by using this 1 ml of the solution of sodium hydroxide. Now I am adding this 1 ml of sodium hydroxide solution into this. So now the solution again increases to 6.16. So likewise the values can be decreases by slowing down this, and increases the first value of HCl, and the second value decreases by using this acetic acid. This is the formation how the values can be decreasing for the weak acid and the strong acid. So the principle behind this procedure is when sodium hydroxide is liberated for this reaction, and it reacts slowly, which reduces the OH group ions, and it has a mixture of acids. From this, the H removed from this HCl, and from the acetic acid, the moving sodium ions can be liberated by this reactions, and it forms as a Na and H, that is sodium and hydroxide groups for the liberation of the reactions. So throughout this, the acetic acid plus sodium hydroxide, which gives a sodium acetate and plus the liberation of water molecules, and with this HCl solution, HCl plus NaOH with the neutralizers to give NaCl plus H2O, and this is the first decreases process which have this first neutralization of HCl and the second neutralization of this acetic acid. So this is procedure. Hence the sodium acetate is a strong electrolyte which has the conductance increases the value for this reaction. So for this, the 1 ml of the solution from the value decreases from 6.34, and another 1 ml we are using this experiment as decreasing the values. So we are adding this again 1 ml to just add 1 ml and titrate the solution. So the again value will decreasing as a 6.46 value decreasing, and another 1 ml is just add by you. Left side So the value again decreases to 6.66. So likewise the value decreases and then again the slight decreases and again decreases and slight increases. So from this we can identify the strong acid and the weak acid, and the calculation how the acetic acid and HCl is improved by using this formula V1N1 by V2. Here the V1 can be substituted by this value of the first decreases value from the graph, that is called as an A, and the value by N2 is a 0.1 of sodium hydroxide, and the starting value of this V2 is the value is 20 ml. So multiply these two reaction and divide them by 20. So we can get the value of volume of sodium hydroxide, that is V1. And again the acetic acid can be noted by the same the formula of V1N1 by V2, and V1 is the second decreases value from the graph, that is B minus A. The B value minus with the A value and the value substituted from the V1, and the N2 value is same as in the 0.1 and divided by 20 ml. So multiply both the equation, both two numbers and divided by 20, we will get this value of V2, that is the following reaction which is followed by acetic acid. From the graph we can identify the value can be plotted from this, that is the conductance value by volume of sodium hydroxide. The volume of sodium hydroxide can be the same as 0 with 10 ml, and we can consider it as a 1 ml readings, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ml, and the conductance value we can adjust it from this point of 0.6 and 0.1 or 1.10. So something the values can be adjusting. From this we are plotting the graph from A value, that is with 0 ml what is the value reading, and 1 ml reading. We can plot the graph by using this scale, and we can adjust the 2 points by using this midpoint of A, and another side by adjusting the point we can join by midpoint, that is called as a B graph. From this we can identify the strong acid first of HCl is decreases, and another one the acetic acid of CH3COOH can be identified. So from this we can identify the volume of sodium hydroxide from the neutral value of graph. Thank you.